A high-temperature carbon fiber nylon for just $40 per kilogram. Sounds really good, but it's time to test it. Welcome to my tech farm. Another Elegoo filament testing, this time PAHT-CF, carbon fiber reinforced nylon. And this box is sent to me by the Elegoo. In exchange for the review, there is no additional payment, but this video and the whole channel is sponsored by Polymaker. The cost of this filament is $40 per kilogram. Of course, this may vary from the country to country. And according to the specifications, it is a heat-resistant material. It can withstand the temperature up to 194 degrees Celsius ambient temperature, high rigidity and durability, no warping, dimensional accuracy. And I couldn't find what is the base material for this. From the specifications, I think it is PA12 or PPA, but from the price, probably PA12. But if I will get the confirmation from the Elegoo, you can see it here. Another property from the website, 20% hybrid fibers will hide layer lines. And this is correct. Usually these carbon fibers hide these layer lines. They are not really visible. But what does it mean, hybrid fibers? I don't think it is a different type of the fibers. I think maybe it's just a simple mix of the carbon fibers and base material, which is some kind of nylon. Print settings, the nozzle temperature between 260 and 290 degrees Celsius, and the bed temperature between 90 and 110 degrees Celsius. And of course, we need a hardened steel nozzle. And another request from the Elegoo is to print this on the century carbon, which is ready for these technical filaments. Usually I print these test objects on X1 carbon. In this case, the results are more comparable to each other, but since I got this filament from them, and basically this was their only request. Don't forget that nylons are very sensitive to moisture and they require drying, but let's see what's in the box. This is very good vacuum packaging and protects better the filament from the moisture, and this bag is resealable on this side, and we have the same print settings which I already mentioned on the sticker. Carbon spool with reinforced edges. Now let's see how brittle is the filament. Not too brittle, but let's measure it. Start angle 20 degrees. Around 110. Definitely not brittle. And it's not even broken completely. Settings in the slicer. On the nozzle to 80 degrees Celsius, 85 on the bed, 12 is the maximal flow rate, and 50% will be the maximal part cooling. Objects are printed on century carbon behind closed doors. The printing was smooth without any problems, even if it is hard to see through this glass. Objects are printed ready for mechanical testing, but I will wait at least 3 weeks, so the test objects will absorb some moisture from the air and be closer to that stable state. Now, Elegoo don't mention anything about annealing on their website, and I know that in most cases users will not do this annealing process. Additionally, I don't even know what is the base material. In my experience, annealing helps against the creeping and temperature resistance, but for this video, I will test these objects without annealing. Tensile test with horizontally printed test objects. Very strong. The results, and for better reference, I will include here the data for Elegoo PAHT-CF from my earlier video, and we can see that PAHT-CF is significantly stronger to the PETG, but overall this is very strong material in this test. Layer adhesion with vertically printed objects. Unfortunately, this is weak. This table is my rating for the layer adhesion with these test objects, and we can see PAHT-CF is quite weak with these settings. Now, I wanted to see if I can improve this with actually heated chamber, for example, but I got the request to use only century carbon. I like better to buy the filament, then I don't have these kind of limitations. Shear test side by side horizontal and vertically printed objects. Printed in horizontal position, very strong, and I was lucky that I could break it with this scale because the maximal on it is 200 kilograms. So overall this property of the material is great. Now printed in vertical position, the effect of the layer adhesion is important, and unfortunately here it is weaker significantly compared to the PETG. Torsion test side by side horizontal and vertical test object. Loaded 90-degree rotation, very similar. 1.1. the maximal load. Printed in vertical position, loaded 90-degree rotation 1.1 Newton meters, but in this case I could continue the rotating and I reached the 2.1 Newton meter load with approximately almost one rotation. Probably there are applications where this may be important. Now printed vertically 1.1 Newton meters, which is fine, but what is interesting here that I could measure even the load at 90-degree rotation, which is quite rare. Usually it breaks more suddenly, so even against this weaker layer adhesion, this is very promising material. 3-point bending test. This sensitivity supports is 50 millimeters. And I'm placing these loads and measuring the deformation after 1, 30 and 60 seconds. Deformation under 5 kilograms and under 10 kilograms, continuously deforming. Not big, but there is some permanent deformation after this test. First of all, we can see less deformation of the PAHT-CF compared to the PETG-CF. But what I don't like here is this. Well, under 5 kilograms it is not so noticeable, but on 10 kilograms we can clearly see that this is far from being horizontal. This means that this nylon don't really like higher constant loads. Impact test with the half kilogram hammer. 0 position. One more time in the slow motion. These are the edge positions of the hammer. 132. I will calculate the breaking energy, but this is tough material. And this is a test where this material shines compared to the PETG or any other material. Even if it is reinforced with carbon fibers, this is quite tough material. Creep test the deformation under constant load. This is PETG carbon fiber, glass fiber, and this is that nylon. Very small deformation. 13.01. Very small deformation. They will be measured every day, but in the video let's jump in a time. 14.26. Let's remove the load. Looks like it creeps and I don't like really this property, but after removing the load the permanent deformation is basically very minimal. On this graph we can see the distance between two reference surfaces, and we can see that the PAHT-CF has less deformation compared to the PETG-CF. But the creeping is the difference between 2 days. And on a second graph we can see that the PAHT-CF have more creeping compared to the PAHT-CF. And this is typical for the nylon, so don't be surprised. Annealing can help here a little bit, but overall I wouldn't place higher constant loads on the nylons. Temperature test in the oven. Even recorded time-lapse is speeded up here. The first deformation I noticed on 212 degrees Celsius, but then it deforms very suddenly, so be careful, don't go closer to this temperature. Soon I stopped the experiment, but it was really melted and stick to this silicone mat. I could easily scrap it off, and don't worry, I finished this outside. Another very important property of this material, it is very temperature resistant, even if I didn't anneal it. Now be careful, don't go closer to these temperatures, because it deforms very suddenly. All results one more time without any additional comments. And this one line will be added to the summary table for my Patreon supporters. This is my only gift for them. Results of the bending test after 30 seconds. Bending test, deformation after 1, 30 and 60 seconds. Torsion test, impact test, and a temperature test. Really budget-friendly nylon, very strong in most cases. Biggest advantages: tensile strength, impact, temperature resistance. Disadvantages: well, a little bit weaker layer adhesion. Maybe we could improve this, but I didn't test it, let's say, with the accurately heated chamber. And also it slowly creeps, so definitely I don't recommend using any kind of nylon under higher constant loads. Annealing may help a little bit, but even then this is very typical property of the nylons. Huge thanks to the Polymaker for sponsoring this video, and also thanks to all my Patreon supporters, because thanks to their donations I can just buy any filament I want to test. Even this one I wanted to buy, but Elegoo was faster and they offered me that they will send these filaments for the testing. Only later I got this requirement to print everything on Century Carbon. Anyway, if you have some other experience with these filaments, write me a few lines down in the comment section. Thank you for watching this video until the end, and happy printing!